Are you not familiar with the basic measurement system analysis? Then this is a perfect video for you. Hello, my name is Pradeep Chavan and I will provide you clear conceptual overview of key topics including bias, linearity, stability and gauge arrender. Let us start with sources of variation. If I measure any product characteristics, there will be the variation and that variation is because of the product variation itself. Along with there will be measurement variation and there will be total variation which will be addition of product variation and measurement variation. Ideally this measurement variation should be as minimal as possible, but there will be always it will be there. So this variation will be called as a measurement error. So let us see what is the effect of measurement error. If I take any product characteristic and I try to measure the average of the product characteristic, then total average will be product average plus there will be measurement error will be contributing to the average of the product. So this measurement error will be called accuracy. Similarly, there will be the variation if I want to measure for the product that will be equal to product variation plus measurement variation, and this measurement variation that is a error that will be called as a precision. So let us understand accuracy and precision in the next slide. Here we will try to understand accuracy and precision by simple example. Here soldier is shooting the middle cross target here. Now let us see how he is shooting. Now here you can see short bullets are away from middle cross target. So it is not accurate. And at the same time they are away from each other. So that is not precise. Let us see this example. Here short bullets are around the middle cross target, but these short bullets are away from each other. So first they are around to middle cross target, that is accurate, and they are away from each other, that is not precise. Let us see one more example. Here short bullets are away from middle cross target. Middle cross target is here and short bullets are here. So it is not accurate. That is a inaccurate. Now short bullets are near to each other. So that's why it is precise. Let us take last example. Now here bullet are close to middle cross target, that's why it is accurate. At the same time they are close to each other, that's why it is a precise. So whenever there is an instrument which is measured with a master and showing the same reading as master, that will be called as accurate. And if I repeated the reading and there will be repetition will be there, reading will be close to each other, then that instrument will be called as a precise. Here we are going to see few terminology which are related to measurement system analysis. Discrimination, accuracy related term, that is bias linearity, precision related term, that is repeatability, reproducibility, linearity and stability. So here, what is a discrimination? The number of decimal places that can be measured by the system. So here, poor discrimination example is this. Here only few decimal places are there, so that will not measure, rather discrimination is poor. So this is the second example is related to good discrimination, and requirement is that increment of the measure should be about 1/10 of the width of the product specification. What is a bias? It is also called as a accuracy. It is a difference between observed average and the master value. So this is a master value and this is a observed average, and difference between these two will be called as a bias. Now let us try to compare accuracy or the bias between two instruments. So this is the instrument 1 which is having this much bias, that is the difference between mean and master value. This is the second instrument which is having bias this much. Now here you can see instrument 1 is more accurate than the instrument 2. What is a precision? It is a total variation in the measurement system. It is a natural variation of repeated measures. It is also called as a random error, spread, test or retest error, and it is divided into two parts. One is the repeatability and second is the reproducibility. So combination or the addition of repeatability and reproducibility gives the total variation. What is the repeatability? It is a natural variation or the variability of the measurement system. Variation that occur when repeated measures are made of the same variable under identical condition. For example, same operator, same setup, same unit, same environment condition. Let us take one example. Now you wanted to measure the repeatability of the vernier. So same variable, that is a, for example, diameter that you wanted to measure should be taken, that should be measured by same operator at same setup, same unit will be followed and same environment condition. So after measurement of diameter by that particular vernier, so whatever variation you will get, that will be called as a repeatability. Let us take case study of repeatability. Repeatability is a variation between successive measurement of same part. So I take a same part and I repeatedly measure the same. So I got this variation which is a less. So this is a good repeatability. Second part I have taken and I measure and successive measurement for which this distribution I got, which is a wider one, and this is a poor repeatability. Now in repeatability master value is not considered, so master value is not involved or not considered in the repeatability. What is a reproducibility? That is a difference in the average of the measurements made by different person using the same instrument when measuring the identical characteristics. So let us take one example. I have taken 10 job. I have asked to measure these 10 job to the three operator, operator 1, operator 2, operator 3, and they got such kind of reading. Now their reading are close to each other, so this is a good reproducibility. Again I ask to measure this job or 10 job, other three operator they have measured and I got this kind of reading by these three operator, so their reading are away from each other, so that is a poor reproducibility. Again, in this case also reproducibility master value is not considered. Combination of repeatability and reproducibility will be giving us gauge R&R. So what is a gauge R&R? That is a process variation divided by measurement variation. If you are saying my gauge R&R is 20%, then this process variation which is shown by the red color divided by this much, that is a blue color band, will be 20%. So if you are saying that is a 75%, then process variation divided by this large band, middle band, that will be 75%. And here in both cases, the last case, that process variation and the measurement variation are same. That's why it is a 10%, sorry, 100%. So what is a thumb rule for the acceptance criteria for the gauge R&R? That is a 10%. So that should be as minimum as possible, gauge R&R. but practically it is not possible. Some natural variation will be always there. So thumb rule is that gauge R&R should be less than 10%. Let us talk about the linearity. What is a linearity? It is a measure of the difference in the bias over a range of instrument capability. Now, for example, this is a Vernier caliper for which we have conducted a bias at different operating condition. For example, at 0, at 5, at 10, at 15. So bias value or the accuracy over a range is different. So this is a line which is increasing. So bias is different. So linearity is a issue here. Second example, over a range, bias value remains same. So linearity is a not issue in this particular case. What is the stability? It is the evolution of the difference in the accuracy or precision over time. Over time is important. Let us take case study. I measure one particular diameter repeatedly over a period of time. At a time 1, I got this much distribution. At time 2, I got this much distribution. At time 3, I got this distribution. Now these distribution are close to each other. At the same time, it is close to the master value, so it is having the good stability. If I take second case, in that particular case over a period of time, these distribution or this value are not close to each other, or they are away from each other, and at the same time they are away from the master value also. So this is a poor stability. So these are the thing regarding the measurement system analysis basic thing. So thank you very much for joining this session. Thank you.